Hello guys, in this video I'm gonna try to get the layout in Encounter, because last time we did that, Encounter crashed and we couldn't demonstrate it. So in this short video I'm just gonna show you how to get the Encounter layout. So we'll start by SSHing into the CAX computers. So let's say Swamp 50, and then we have to SSH to one of the newer computers that can run Encounter, which are Swamp 36 till 45, I think, or 44. In my experience, Swamp 43 is a really good computer. So let's try that. SSH Y and Swamp 43. And then, as usual, we just go into the project directory and run cat setup 45. In here, okay, so here last time, if you remember, we synthesized the Verilog files and we got the .vh file. If you remember, the .vh file is the Verilog netlist, which is the output of the synthesis. Now we've already, in the previous video, we've already edited this file in counter.conf. That's the file we edited, and the only line we edited was here, where we put the name of the top level module in our project. So this is the name of the module, the top level module in the Verilog file. So all that's left to do is just one simple command. We tried this command last time, it crashed, but now it's fixed. The command is encounter /init and then encounter.tcl, not .conf, which is the file we used earlier. We don't use that file, we use a TCL file. So this is the command, and hopefully it will work this time. So right now we'll just take that netlist, and it's running a bunch of algorithms to place and route. So it will place all the cells and then route them together into different layers, metal 1, metal 2, up to metal 12 maybe. And if everything works out great, then we should see that layout displayed hopefully very soon. And here we go. It's a little bit slow because I'm running this from my house, which is so there's a bit of latency for the connection to campus, but yeah, that's why it's taking a while. But we should see the layout right now. So this is the layout of the 8-bit adder we wrote a few weeks ago, and it automatically placed the cells and routed them together. Now if you see these two rings, the inner ring and the outer ring, these are in fact the ground and VDD. Not sure which one is VDD, which one is ground, but one of the rings is VDD, one of the rings is ground. And the reason they do it this way is for shielding purpose, to shield the core, and for ease of connection to the core. When you have them like that, then you can connect VDD and ground from any point very easily inside the core, because they're all around the core. And they're very thick because they need to supply a lot of current. Now, if you let me zoom in to show you the cells and the routing. So these are the different cells. So if you can see, this is a register 4, register 7. And these connections here are the VDD and ground. So that's how they place them to maximize, to minimize, to maximize space efficiency. They place them horizontally like that. And so I'm not sure how we can tell, but this is basically metal 1. The blue connections over here are metal 1, and the other connections here are different kind of metal. For instance, this could be metal 2, I'm not sure, but anyway, it's not that important right now. The only thing left to do right now is to actually just find out the area. We already get a rough estimation of area from the synthesis reports, but it's a very rough estimation. We need a more accurate estimation from here, and to get that, we go into design and report and summary. Also, if you can see here, these are the input-output ports to the adder. So you have some here and some here, some here, some here. Not sure which ports exactly these are, but these are the input-outputs. If you just wait for this. Okay, let me open it again. Seems like it froze again. Alright, here we go. So design, report, summary, and the report will actually be an HTML file which we can view in a web browser like Firefox. So we put this as HTML and text, and we leave things as they are here and press OK. And now it should generate the report. And after it generates it, we can go into Firefox and actually view that HTML page report. Apologies for the really bad connection. It's not normally this bad. I'm not sure what's happening. Here we go. So the report is done. Let me close Encounter. Alright, so Encounter is done. Now the report will be inside the folder called Summary Report. So we go into that folder, and in that folder we open, so there are a bunch of HTML files here. The one we want is our top level, which is adder8bits.main.htm. So it's the first file that you see in an ls command. So we open that in Firefox. And now there's going to be a long wait because of my connection, but once it opens, it's a very organized display of my layout, basically the area, the cells. So it's just one value that I need from there, the area, and once it opens, show you that, and we're done. Okay, so in this section it just displays a number of cells, a number of standard cells, number of input-output pins. These are not very useful to us. Here there are the number of layers, the routing layers. So there are 10 metal routing layers used. What else? Anyway, the important information here is this section, floor plan and placement information. Here it will display the area information that's relevant to us. The two relevant parameters that you should look at and include in your report later on are these two: total area of core and total area of chip. Now the total area of core is in fact that the gates and the cells without the two rings on the outside. If you remember these two large rings on the outside, so this first value does not include these two rings. The second value, total area of chip, actually includes the VDD and ground rings surrounding the core. So this is just the core, this is just the chip, and you should report these two values in your project. And this is it. Good luck in your project, and if you have any questions, just let me know.